So we're on analyzing parts of graphs, part 3, and now we're talking about symmetry. A function can either be even, odd, or neither. So for a function to be even, we plug in negative x for x. We check to see if all the signs stay the same. That makes it even. And then it would be symmetric about the y-axis, is what we could say. So here is a picture of one that's even. I used a printed copy to make it look really nice and symmetrical that I might not have been able to do by just drawing it by hand. Then they labeled this function over here, h of x equals x squared plus 1. So I wanted to show you what we're talking about in these steps. So if we literally replace x with negative x, so we say now negative x squared plus 1. Well, that would equal x squared plus 1. So my signs from the beginning to after I plugged in negative x, they stayed the same. So that's why we would say this is an even function. They all stayed the same even when I substituted negative x for x. And on a graph, it would look symmetrical about the y-axis. So then if my function is odd, we plug in negative x for x again, and all the signs change this time, and then we would say it's symmetric about the origin. So this is a picture of one that's symmetric about the origin, and it is odd. So let's examine this equation here. They said g of x equals x cubed minus x. So then if we plug in negative x in place of x, notice how negative x cubed now becomes negative x cubed, and then negative times a negative x becomes positive x. So from our original function to after we plug in negative x in place of x, both signs changed. So then this is an odd function. And when we say it's odd, it should be symmetric about the origin. So again, I used a printed example so that it looks really nice and symmetrical about the origin. So notice it's symmetric about this little line right there. And then let's look at an example of what would be neither. So neither is when you plug in negative x for x, but then only some of the signs change, and we say it's not symmetric. So I just wrote out an example, 2x squared minus 3x plus 2. So if we substitute negative x in place of x, let's see what happens. We end up with 2 times negative x squared, which does stay the same. Negative 3 times negative x becomes positive 3x. So notice 2x squared stayed the same, negative 3x became positive 3x, then 2 stayed the same. So some signs stayed the same. Not all of them. So this one would be neither. It's either all or nothing. So if all the signs stay the same, it's even. If all of them change, it's odd. And if some of them change, it's neither. So also remember for the odd ones, it's symmetric about the origin. So like the O's go together. O and odd and origin are all O words. And then you can remember the even just goes with the y-axis, hopefully. Let's look at a few more examples. So just to practice that for just a second. If we're given example 1, and we have x squared minus 4x minus 1, we want to substitute negative x in place of x, and then simplify. So we would have negative x squared is equal to positive x squared. Negative 4 times negative x is positive 4x, and then minus 1. And so then we look and see what happened. So this sign stays the same. This one changed, and this one stayed the same. So this one will be a neither. If we put in negative x for x again in number 2, so notice leave that negative, and then you're still replacing just that x with negative x. So then it would be negative x cubed, then minus 2x. Then those would change to positive x cubed minus 2x. So then we look back and we had a negative and a positive, and now we have a positive and a negative, and so both signs changed. So this one would be odd. Now let's look at the last one. So if I put in negative x in place of x again, I would still have 5x to the fourth. This would be a negative x squared, but it would become a positive, so that's still going to be negative 2x squared. So all the signs stayed the same, so this one is even. So then when it's neither, we say it's not symmetric. When it's odd, we say that it is symmetric about the origin. So we just write that out. When it's even, we say it is symmetric about the y-axis. Alright, so that's it for symmetry.